Hello students, welcome to my class. During my lecture session, I have discussed the theory related to this chapter. Today, I am going to discuss the questions related to this, completely based on your CBSE pattern, completely based on NCERT pattern. So, let us start the topic here. That is the question number 1. What is given here? Check it out, my friend. In a process 701, solution. In a process 701 joule of heat is absorbed by a system. Yes, heat is absorbed by a system. That is Q is equal to, my friend, 701 joule. Yes sir. And 394 joule of work is done by the system. Work is done by the system is minus 394 joule. Yes sir. What is the change in internal energy for the process? Given here change in internal energy, that is delta U, or you have to find delta E. This is the case. Yes sir. As we know, according to first law of thermodynamics, delta U is equal to Q plus W, and delta U is equal to, what is Q here? That is 701 W minus 394. After solving, what we get, my friend? That we get, that is the internal energy. Am I right? Yes sir, you are absolutely right. Simple question, you can easily solve such questions. Now, let us move to the next. Wait for a moment. Now, the next question, look at, what is the question number 2? The solution, or you can say the answer of this question. For an isolated system, delta U is equal to 0, what will be the delta S? Suppose I am taking a isolated system, that is I am taking two gas bulb filled with different type of gases, and they are connected by a valve which is maintained by, which is stopcock. This is an example of isolated system which is maintained by a stopcock. Yes, this is the case. Yes. Now, the gases are filled here. The gases are filled here. Clear? Now, as we know, this is the isolated system, that is delta U is equal to 0 given. Yes. When this stopcock is opened, what will happen? The gas will start to flow and intermix with each other. Intermixing, that means to say the randomness increases here. If randomness increases, then what we know? That is, my friend, entropy increases. Yes, entropy increases. That means to say delta S becomes positive. So, in this case, what will happen? That is delta S become positive. Now, let us move to the next question, next explanation. What is given? Wait for a moment. The next one is question number 3. This is a question. Read the question first. For the reaction 2A plus B gives C, delta H is equal to 400 kilojoule per mole. Yes, and delta S equal to 0.2 kilojoule per mole. At what temperature will the reaction become spontaneous? Considering delta H and delta S to be constant over the temperature range. Yes. spontaneous, that is, we know the reaction is spontaneous only when, the answer of this question, the reaction is spontaneous only when, that is, the delta G becomes negative. Yes, as we know, delta G is equal to delta H minus T delta S. Suppose it is in an equilibrium situation, put here 0, equilibrium, that is delta G is equal to 0, is equal to delta H minus T delta S. Yes, we write here delta H is equal to T delta S, or T is equal to delta H upon delta S. Delta H upon delta S. What is delta H, my friend, given here? That is 400. And what is delta S? 0.2. Point will come here. What we find here? That is 2000 Kelvin. T is equal to 2000 Kelvin. Clear? Now, if I increases the temperature, that is above 2000 Kelvin, then what will happen? Listen carefully. Above 2000 Kelvin, the formula is delta G is equal to delta H minus T delta. If temperature is more than 2000 Kelvin, more than 2000 Kelvin, what we observe here, this becomes negative. Ultimately, this entire terms become negative, which ultimately make delta G negative. If delta G negative, the process is spontaneous. So we people can say above 2000 Kelvin, the process will be spontaneous. At 2000 Kelvin, we will say delta G is equal to 0. And below 2000 Kelvin, the process is non-spontaneous in nature. This is the case. This is a technique to solve this type of questions, because equilibrium is the borderline, you can say. Clear? And by putting the value, you will get the final output. Am I right, my friend? Yes, sir. Now I am going to rub this and we will discuss the next question. Wait for a moment. And next question here, question number 4. Think on it, what is given here, my friend. 2Cl gives you Cl2. What are the sign of delta H up and delta S? Tell me. What are the sign of delta H and delta S? Look at 2Cl converted to Cl2. That is atomic form converted to molecular form. That means to say the bond formation take place. Yes, sir. If there is a bond formation take place, then what will happen? It's very simple. We know release of energy take place. Release of energy take place. That means to say delta H becomes negative. So for this reaction, delta H becomes negative. What about the value of delta S, my friend? Yes. This is in the atomic form converted into molecular form. That is the particle closest to each other. If and there is a bond formation take place, that means to say when bond formation take place, we know randomness decreases. Again I am telling, the randomness here decreases. If randomness decreases, then what do we observe here? That is the entropy decreases. Yes. Entropy decreases. That is delta S becomes negative, not positive. So what are the sign? Delta H negative and delta S also negative, not positive. Clear? Yes, sir. Now let's move to the next question. Wait for a moment. Now the next segment, look at again, there is a two part of the question. First of all, I am giving you few seconds to read the question. The equilibrium constant for a reaction is 10. What does it mean? It means it is the solution number 1. Equilibrium constant, that is the value of K is given, K is 10. What will be the value of delta Z? Okay, standard gives free energy. As we know, delta G is equal to minus 2.303 RT log K. Am I right? Yes, sir. Now put the value here. Delta Z is equal to minus 2.303. What is R? R is, my friend, 8.314. What is T, my friend? That is 300 Kelvin. And what is the equilibrium constant is 10. Clear? Now we know log 10 is equal to 1. So the delta G value is equal to minus 2.303 into 8.314 multiply by 300. After solving, you can get the answer. Am I right? Yes, sir. Definitely you are correct. Now, next one. Extensive property depends on the quantity of matter. During my lecture, I have discussed this, but the intensive properties do not. Intensive property do not depend upon the quantity of the matter. So, what is given here? Which one is intensive and which one is extensive? That is, you have to find out which one is intensive and which one is extensive. Clear? Now, here is given mass, internal energy, pressure, mass, quantity. This one is, my friend, that is external property. Now, internal energy, again there is a quantity involvement. This is also example of external property. Pressure, force per unit area, that is internal energy, my intensive property, intensive. Heat capacity, again there is a mass involvement. Clear? So this is a extensive property. Yes, molar heat capacity per mole, that is a fixed value. So this is intensive property. Density, mass per unit volume, this is intensive property. Mole fraction, that is intensive property. A specific heat capacity, it has a fixed value, intensive property. Temperature, intensive property, does not depend upon the quantity. And the molarity per mole, intensive property. These are the case. Extensive, intensive, extensive, intensive, temperature intensive, and molarity intensive property. Those property which depend upon the quantity of the substance, these are known as extensive property. Those property which does not depend upon the quantity of substance is known as, my friend, intensive property. I think you can easily solve such kind of questions, my friend. Now, I am leaving this question for you. Read the question carefully, what is given here. Can you do it for me? I am giving you few seconds to think on it. Okay? Now, think on it. So, I think you have got the answer. What is the answer of this question? What will be the standard enthalpy of formation of H2O? The simple explanation here, that is H2 plus O2, which gives you H2O. Clear? H2 plus O2, which gives you H2O, and the delta H of the reaction is minus 572. Delta H given here. Now, what we need to find? We need to find the enthalpy of formation. That is, we need to find H2 plus half O2. That is the enthalpy of formation, means that is the formation of 1 mole of H2O. So what will happen? The enthalpy of formation of water will be equal to upon, that is 2 divided by 2, we get this answer, upon 2 minus 572 divided by 2, that is minus 286 kilojoule per mole, my friend. This is the case. Clear? This is the case. This is the method to find out. This is the delta standard form reaction, heat of reaction, and enthalpy of formation only stand for 1 mole. Clear? So delta H formation will equal to delta H reaction upon 2, 1 mole divided by 2. If I divided by 2, 2 here and 2 here, we get this one. So also divided by 2 here. That's the question. Clear? Now I am going to rub this part, my friend, and we will discuss the next point. Wait for a moment. Now let's move to the 7th. What is given? Read the question carefully. An ideal gas is allowed to expand against a constant pressure of 2 bar from 10 liter to 50 liter in one step. Okay. Calculate the amount of work done by the gas if the same expansion were carried out reversibly. Will the work done will be higher or lower than the earlier case? Okay. As we know, work done is equal to what will happen? Minus P external V final minus V initial. What is the external pressure here is, my friend, 2 bar and 50 minus 10, because V final, yes. Then W is equal to minus 2 into 40, that is, my friend, 80 bar and liter. We know we can convert ATM, bar into ATM and liter into kilojoule. That does not matter. What we observe here, W is negative. This negative sign shows that work done by the system. Now, if the same expansion were carried out reversibly, here is given also 1 liter bar is equal to 100. So if you multiply by 80 into 100, then what do you observe? 8000 joule. Clear? Now, if the same expansion is carried out reversibly, will the work done be higher or lower? Definitely the work done will be higher. Why work done will be higher? Because each and every step, the value of internal pressure and external pressure almost remains same. Due to this reason, if reversibly, work done will be higher. This is the correct, not lower. Am I right? Yes, sir, definitely. This is the question number 7. So let's move to the next one. Now, the next one is question number 8. What is given here? The reaction of cyanamide NH2CN with dihydrogen in a bomb calorimeter and delta U was found to be minus 742.7 kilojoule per mole at 298 Kelvin. Calculate the enthalpy change for this reaction. Yes. As we know, delta H is equal to delta U plus delta NgRT. This is the formula? Yes, sir. Now, delta H is equal to, what is delta U, my friend? Given here, minus 742.7 kilojoule. What is delta Ng? As we know, delta Ng, number of moles of product minus number of moles of reactant. Product here in gaseous, 1 N2 and 1 CO2, that is 2 product, and in reactant side this is solid. We will not consider solid one, 3/2. 2 minus 3 by 2, that is 4 minus 3 by 2, my friend. Yes, 4 minus 3 by 2 will be equal to 1 by 2. This is the case. So put here, that is delta Ng is equal to 1 by 2. So what is 1? 1 by 2. 1 by 2 into R. What is R? The value of R will be taken into not joule, in kilojoule, because this value is given in kilojoule. So 8.314 divided by 1000. Now this is kilojoule and the temperature is given 298. Am I right? Now if you solve this problem, then you can easily get the value of delta G. Again I am repeating, delta H. Delta H is equal to delta U plus delta NGRT. Delta Ng, number of moles of product. Here this one will not consider in liquid state. N2, 1 plus 1, 2. 2 minus 3 by 2. I am checking the minus sign. 2 LCM 4 minus 3, that is plus 1 by 2, not minus 1 by 2. Now if you solve, you will get the answer. Clear, my friend? This is the explanation. Clear? Yes, sir. Now let's move to the next question. What is given here? Given that delta H is equal to 0 for mixing of two gases. Yeah. Explain whether the diffusion of these gases into each other in a closed container is a spontaneous process or not. Yes. Okay. As we know, if the process is spontaneous, then delta G will always be negative. For the spontaneity of a reaction, that the value of delta G should be negative. Okay. As we all know, delta G is equal to delta H minus T delta S. In the question given here, delta H is equal to 0. So what we observe? Delta G is equal to T delta S. Yes. Now when the diffusion take place, with these gases into each other in a closed vessel, if the diffusion take place, then this delta S becomes positive, entropy randomness increases. If delta S become positive, that is the quantity increases, the value increases. If value increases, this overall term will be more and more negative. If the overall term will be more and more negative, what we get? Delta G. We get maximum negative value of delta G. If we get a maximum negative value of delta G, then the process is, my friend, spontaneous. It's very simple. Then the process is spontaneous in nature. Am I right? Yes, sir. Now I am going to rub this and we will discuss the next segment. What is given here? The next question is question number 9. Again, what is given? Calculate the standard enthalpy of formation of CS3OH. I am moving here, my friend. I need a space here. Question number 9, solution. Enthalpy of formation of CS3OH. As we know, CS3OH forms C plus H2 plus O2, which gives you CH3OH. This is the case. Clear? C plus H2 plus O2. Wait for a moment. Clear, my friend? Now balance them. 2.5 O2. This is the case. We have to reach here, and for this reaction we have to find the delta H. Clear? Now we have three equations. CH3, let me once note down. CH3OH plus 3 by 2 O2. It gives you, that is, CO2 plus 2H2O. Clear? The reaction is minus 726 kilojoule per mole. This is the first. Yes, sir. Now mark it as a equation 1. The next one is C plus O2. Again I am repeating, C plus O2. It gives you CO2. Clear? Heat of reaction in this case is minus 393 kilojoule per mole. Clear? Now the next one is H2 plus half O2. Yes sir. Now it gives you H2O. Clear? That is heat of formation is minus 286 kilojoule per mole. So mark it, this is equation 1, mark it, this is equation 2, and mark it, this is equation 3. Now the question here, by using these 3 equations you have to reach here, and when you reach here then you can easily find out the standard enthalpy of formation of CS3OH. Now tell me what to do. In this case, what to do, tell me. Is very simple, we can easily do. Look at, if I add equation 2 and 3, what will happen? If I add equation 2 and 3, and then what do we observe? Equation 2, C plus O2, and divide it by equation 1. So equation 2 H2 one time, here is H2 2 times, better to multiply by 2. Now the term is here, equation 3 multiply by 2 plus equation 2, yes, minus equation 1. Let's check, am I right or wrong? H2 multiply by 2, 2H2 plus half O2 into 2, that is O2, it gives you 2H2O. 2H2O. First one. Second one is C plus O2. It gives you, my friend, CO2. So first add them. 2H2 gas plus O2 gas plus C solid plus O2 gas gives you, that is 2H2O liquid plus CO2 gas. Now equation 3 into 2 plus equation 2 minus equation 1. Now subtract this overall with equation 1. Then what do we observe here? Yes sir. Now I am going to rub this part. And we will do like this. Now 2H2, yes sir, then O2, yes sir, let me note down once, my friend, plus C plus O2, okay, minus CH3OH liquid minus 3 by 2 O2 gas. It gives you, that is, my friend, 2H2O liquid plus CO2 gas minus CO2 gas minus 2H2O. Now you can see. Big question, that's why. This is the case. Now what will happen? Look at. This will cancel this one, this one, this one, okay. Now O2 plus O2, that is 2O2, okay. Now right here 2H2, now arrange them, C plus 2H2, clear. Now O2 plus O2, that is 2O2, 2O2 minus 3 by 2O2, that is 1 by 2O2, yes sir, 1 by 2O2. Now move this one here, so what we find? CS3OH liquid. Look at, we have reached our destination. So we can easily say delta H formation of CS3OH will be equal to equation 3 multiplied 2. So what is the formation? That is minus 286 multiplied by 2. plus equation 2, that is minus 393. Clear to you? Now then minus 726. Now if you solve this one, you will get the answer 286. Equation 3 multiply by 2. I'm moving. This one is 3 multiply by 2 plus equation 2, yes, plus equation 2 and minus equation 1. So minus equation 1, I'm moving, that is minus 726. If you solve, you will get the answer. I think now you can easily do it, my friend. Let's move to the next segment, the next question. What is given here? Now the question number 10. At 298 Kelvin for the reaction N2O4, the reaction is N2O4 in a gaseous form, that is gives you 2NO2 at gas. Am I right? Yes. Predict whether the reaction is spontaneous or not if the value of K is 0.98. Okay. For the spontaneity of a reaction, we know that is delta G should be negative. As we know, delta G is equal to minus 2.303 RT log K. If I put the value of K, what we observe, that is minus 2.303 RT log 0.98. You have the value of R, you have the value of 2, you can also put. What do we observe? That is we get the value of delta G negative. If we solve, then we get the negative value. That is, if the value of delta G is negative, then we can say the process is spontaneous, my friend. Again I am repeating, then we can say the process is spontaneous in nature. Am I right? Yes, sir, you are absolutely right. Now next, identify the state function and path function. As we know, state function depends on the initial and the final value, and path function depends upon the overall path followed. Clear? Is very simple. Enthalpy is a state function, entropy is a state function, but heat we know the path function. Temperature state function, work we know path, area under the curve. Free energy again a state function. So which one is a path function? Work and heat are path function. Rest, enthalpy, entropy, temperature and free energy are, my friend, state function. Clear to you? Yes, sir. Now let's move to the next one. Heat capacity is an extensive property, yes, but the specific heat is an intensive property. What will be the relation between Cp and C for 1 mole of water? Okay, heat capacity for 1 mole of water will be equal to 18 into a specific heat capacity. We know the specific heat capacity is equal to 4.84 joule per gram per Kelvin. Clear to you? Now put this value, what we get, Cp is equal to 18 multiply 4.18. This is the case, this is the relation, my friend. Again, a specific heat capacity here, that is a specific heat capacity, that is Cp, here the mass, that is it is an extensive property, but C is fixed whatever the condition, and this C is, my friend, a specific heat capacity which value is fixed 4.18 joule per gram per Kelvin. Put the value, you get the relation. Cp is equal to 18 into C, because here is given only 1 mole of water, my friend. Am I right? Yes, sir, you are absolutely right here. Now next question is given here. The net enthalpy change of a reaction is the amount of energy required to break all the bonds in reactant molecule minus amount of energy required to form all the bonds in the product molecule. Okay, what will be the enthalpy change of the following reaction? Here the bond energy given. As we know, enthalpy change for the reaction is equal to bond energy of the reactant minus bond energy of the product. Am I right? Again I am repeating, enthalpy of reaction is equal to bond energy of the reactant minus bond energy of the product. What is the bond energy of the reactant? That is the bond energy of H2 and Br2. H2 is 435 and Br2 is 192. So heat of reaction is equal to 435 plus 192 minus bond energy of the product, that is HBr, 2 into 368. So after solving we get the value. Here is not product minus reactant, here is reactant minus product. 435 plus 192 minus 2 into 268. 2 into 368, sorry, pardon, 368. This is the question. I think you can easily solve now each and every question related to this chapter. Basically, you have to focus on thermochemistry part as well as the numerical related to the first law of thermodynamics. Clear? Still, if you have any doubt, you can easily approach to me. So my friend, time has come, time to say bye-bye. Thank you so much.